Angular builders are nodejs scripts executed by Angular CLI and perform different tasks like application build, serving the application, or running end-to-end or unit tests. You can create your own builders that can perform very specific tasks for your Angular application, and from this video you will learn how to do that. At the end of this tutorial we will build a custom builder that patches the application build information in a dedicated JSON file. This JSON file name can be configured by providing custom options for the builder, and additionally you will learn how to schedule another target from your custom builder. This information might be very useful for senior Angular developers and architects, so if it sounds interesting to you, please continue watching until the end, and I'm pretty sure you will learn a lot of cool stuff today. My name is Dmitry, and on my YouTube channel you will find a lot of advanced Angular tutorials that you can check out later, but for now let's get started and create our first custom builder. Alright, here I've got the following application that does very simple thing. It just prints some build information about the app. You can see here the application version and also the build date, which is not provided yet. And this is how I have implemented this application. Actually, it consists of just one component, and inside the ng on init lifecycle hook of this component, I do the HTTP call to the some build JSON file, and the data that is being returned from this file I render inside the component template right here. So this is the version and the build date, and the build JSON file lives under the assets folder, and as you can see, it's a very simple one. It has just two properties like version and date, and the goal of this video is to create a builder that will be patching this information. So this builder has to go to the application package.json file and read this property, take this version and insert it inside the corresponding property inside the builder.json file, and also it has to update the build date with some timestamp. So a pretty simple task, so let's get started with the implementation. So first of all, we would need to create some additional architect target in addition to currently existing ones. So here somewhere below I can create a new one, and I can name it like, I don't know, patch build info. So something like that, and like every architect target, it has to have a property called builder, and this property already points to the builder, to the script that eventually needs to be executed when we run this architect target. And if you watched my previous video, you know that the builder string consists at least of two parts separated by column. The first part is a path to the package where the builder lives. It can be some relative path if for whatever reason you decided to store your builders within the same workspace as your Angular application. So you would most probably have something like separate folder for your builders, and you would have something like that. But also it can be the name of npm package, and this is something I'm going to do in this video, because most probably this is something what you will have in real applications, because you want to create a builder once and reuse in your whole application. So I will create the package, npm package, that will have some namespace like Decoded Frontend, and the name of the npm package will be something like build info, right? And the second part of the builder string, it is the name of the builder itself, and I'm going to name it as a patch, because I think it perfectly describes the intention of this builder. And in such a way we just created our first custom architect target that we can actually try to execute. And in order to execute custom architect target, we have to run the following command. So you have to run ng run command, and then you have to provide the name of the project this custom target belongs to. In my case, the project name is Angular Custom Builder Example. And then after the column, you have to provide the name of the actual architect target you are going to execute. I'm going to execute the target I just created, which has a name patch built in 4. But obviously when I run this command, I will get an error because we don't have this builder created, so the proper node package could not be resolved. And this is something we're going to fix right now. So I've created an additional project that is currently just an empty folder, and I'm going to turn this empty folder into the npm package that provides the builder that will be doing some useful stuff for me. To be a valid npm package, this folder should have at least one file called package.json. You can create it manually, of course, but you can also run the special command called npm init. And here you will be asked about a couple of questions like package name. And if you remember, I decided to name it like that. So let's grab this name here and provide it. And then you should answer and provide some data like description. I can type here something like Angular CLI builder that patches the build in 4. The entry point, we don't even need it. Test command we can skip, git repository as well. Here you can place your name, like I will type my name. Here we go. And then if everything looks okay, we press enter and the package.json will be generated for us. And I think I don't need this main property, so I leave just the following content inside my package.json file. All right, looks awesome so far. And now, if you remember again from my previous video, when Angular CLI tries to resolve a builder, it goes into the package, and there it parses its package.json file and tries to find a property called builders that points to the JSON file that describes all available builders in this package. So let's create such a property right here. So it's going to be builders, and it will point out to some builders JSON file, something like that. And obviously we have to create such a file, so let's create it next to package.json file. Cool. And now we have to describe our builders, and we can do it the following way. So we have to introduce a property called builders, and here there will be an object. Here we already provide a builder where the key will be the name of the builder. So as you remember, I decided that my patch builder will have a name patch, so I will take this name and provide it as a key inside the builder's object. And the builder itself is being described by 3 properties. First, it is a description where you can give some information that makes sense, like it patches application built in 4, something like that. And besides that, it should have 2 another properties. The first one is called implementation, and this property points to the nodejs script that needs to be eventually executed. And in my case, it will be inside a dist folder that will be automatically generated after the TypeScript compilation. Then this builder will have the corresponding folder, and there will be some index.js file that will be executed, but if you call it as an index.js file, you can just drop it and it will be picked automatically, right? And the third, and it is also required property called schema. This is the property that describes options that could be provided for this particular builder, and it should point to some again JSON file, and in my case it will be again under the dist folder. Then it will be in their dedicated folder for this builder, and it will be called schema JSON file. So like that. Now we are ready with describing of the patch builder, and we can create a corresponding files for that. But I cannot just go and create those files under the dist folder. I mean, technically you could do that. If you decided to go with vanilla JavaScript, then fine, just go and create JavaScript file and execute it. But I'm going to use TypeScript, and I want to have those files compiled from the TypeScript source code. So that's why I need to create a dedicated folder that I'm going to name like source, and there will be another folder for the corresponding builder. I call it patch, and there already I can create a file that I'm going to name like index.ts, and right next to it I will also create schema JSON file like that. But before I start to type any code in one of those two files, I would like to create some compilation pipeline first. And this compilation pipeline will consist of a couple of npm scripts that will be building my TypeScript files into the JavaScript and move the corresponding JSON files into the proper location under the dist folder. And to create those scripts, I would need to install some npm packages, and namely I would need to install the TypeScript itself. Then I would need to have the package called copy files. This package helps me to easily move different files into different locations. And the third package is called rimref. This package helps to clean up some folder, and it does it across platform, so it will be working perfectly on Windows, on macOS, or on Linux computers. So I hit enter and install those dependencies. Here we go, and let's get started with the compilation of TypeScript files. And to achieve that, the first thing we have to do is to create tsconfig JSON file. So here we go. And here inside I just dropped the minimal config for this project. It looks like this one. I hope that nothing surprises you here, because this config is really straightforward. So it includes all the TypeScript files under the source folder into a compilation. It excludes node modules from the compilation process, and yeah, the output of this compilation will be under the dist folder. And what is also important to mention, that module needs to be set up to the common JS. And this is pretty much it. The next step is to create a corresponding script right here. So instead of test, I will create the script that has name build, and right here we will do the following command. So we run rimref and then dist, so we will clean up the dist folder, and after that we will run a TypeScript compiler by running just this command, and that's it. So now if I save it and if I try to run npm run build, you will see that the TypeScript files, they were compiled, and the output, the index.js file, was placed under the dist patch folder exactly as we expected and described into the corresponding implementation property inside the builder's JSON file. But additionally, we see that under the dist patch folder, there needs to be located also the schema JSON file that describes the available options for our builder. So that's why we have to create another npm script that will be moving those files in the proper location. And I will I want to execute this builder right after the build. So that's why I will use the prefix post, and then I will provide the name of the script, after which one we have to run exactly this command, this script. And here inside I'm going to use the package I already installed, namely copy files. And here I say that please move all the JSON files under the source folder into the folder with the name dist, right? So let's try to save this file and run npm run build command again. And as you can see, there was compiled TypeScript, and exactly after that there was executed the copy files script, and it's supposed to move all our schema.json files into the dist folder. So if I open it, you can see that it was indeed moved, but the problem is that it placed under the wrong location. It placed it under the dist source patch, but we don't want to have this behavior. We want to cut this source folder from the path, and we can actually provide the corresponding property for that. It's called app, and as an argument for it, it will be number 1, and it means that the first kind of section of the path needs to be cut. And after that, if I save it one more time and run this command, you will see that my schema.json file was moved in the proper location and located next to the builder index.js file. All right, it is already cool. We can build properly our package. However, it will be inconvenient to run npm run build command every time when we change the code and we want to reflect the changes. So I would suggest you to create a third script that will be compiling our npm package in watch mode. So I'm going to name it like build watch, like that. And here we will do the following thing. First of all, we would need to install one additional package, and the name of this package is TypeScript watch, and let's install it as a dev dependency. So here we go. And by the way, I think we have to move all those guys under the dev dependencies because they are dev dependencies, obviously, and this one I can remove. So here we go. And here we'll be using this TypeScript watch package, and every time the TypeScript source files were successfully recompiled, I'm going to execute npm script post build that copies the schema.json file under the dist folder, because every time when we recompile TypeScript, the dist folder will be recreated, so my schema.json file will be deleted, and that's why I need to again move the schema.json file into the dist folder after each recompilation. All right, so now I think I'm done. I can save it, and let's try our watch script. So I type npm run build watch, and it's supposed to successfully recompile stuff. So once I place here something like console log and say like it works, it should reflect the changes in the compiled JavaScript file. So our scripts and the compilation pipeline overall works fine. And already now, finally, we can start implementing the custom builder. It took some time to set up all those stuff, but anyway, you would need to do that, and that's why I decided to not skip this important part. So let's remove this code so far, and before we start to create actual builder, let's install additionally some npm scripts that are required in order to make it work. So first of all, I'm going to install the nodejs types. So let's do it like that. Then we need to install the Angular DevKit Architect and Angular DevKit core packages. So here we go, and let's save them as dev dependencies. So I hit enter and they should be installed, and yeah, they were installed successfully. So we are ready to go. Just let me quickly close all these panels and focus exclusively on the builder code. So eventually, builder is just a JavaScript object that has some specific shape. That's it. We should not care about the shape of the builder itself, because there is a special function that allows us to create the builder. And this helper function we can import from the npm package that we just installed, and namely it is a Angular DevKit Architect. And right here we can import create builder function. Once we have it imported, we have to export as a default the result of what this create builder function returns. And as an argument, this create builder function expects some simple function that has to return the specific object, which has at least one property called success, and it needs to be the boolean, some true or false, right? So by default, I will return true, and this is the minimum setup in order to make it a proper builder that Angular CLI can eventually execute. But here in the body of the callback function, feel free to do whatever you like. So this is the place where the builder logic lives, right? This is just eventually Node.js script, so you can here read files, write files, and do whatever you want. What is also important to mention about this callback function is that this function takes two arguments. Actually, it is options, and it also takes the context. Builder options, those are options that we are going to describe in the schema.json file. And by the way, currently it is empty one, and it is wrong because even if we don't have any properties, it needs to have the following content there. So like, keep in mind that. But let's get back to the builder code and a few words about the context. Context, this is quite useful object that exposes some useful helper functions or properties, like you can get the path to the root workspace of your Angular application, or it exposes also logger option, which allows you to print some message during the builder execution, so we can let user know that the patching has been started, so something like that. And yeah, a lot of interesting things are located here. Some of them we will use in this video, some of them you can investigate on your own, but this is already ready for usage builder. It's pretty useless, but we can already install it into our target project and try to execute it. However, despite this builder package has been declared in the target project right here, it doesn't mean that this package is currently visible for the target project, because we didn't install this package. And we can install the package a couple of ways. The first one, we can install it from the npm registry, like we usually do with npm dependencies, but this is the approach I want to avoid, because it will makes me publish my library to the npm registry, and then I would need to republish it again when I change the code, and it will be a little bit cumbersome. And there is another way that allows you to install npm packages and without need to publish them to npm registry. Here I'm talking about npm links, and it will allow me to link this package in my target project with my library here. And this is how you can do it. So First of all, you have to create a global link for this npm package on your computer, and for that you just have to run npm link command, so something like that. So once you did that, you can run the following command that will show you all the global npm links available on your computer, where the name of the link is the same as a name of some certain package. In my case, it is the same as a name I defined in my package.json file. And also you can see that this link points to the certain path on my computer where the code for this library exists, right? Of course, anytime you can remove this link if you don't need it anymore. You can run just npm rm, means remove command. Then you have to define that you remove it globally, right? And then you have to provide the name of the link that needs to be removed. In my case, it will be this one. So let me paste it here, press enter, and you can see that package was removed. And if I list again the global links, it will be empty. But again, I want to install this link globally, so I will run npm link command again. And once I have this link again installed, I can link it to my target project right here. So I have to open the console here, and here I run npm link and then the name of the link I just created. If you run like that, it will create an appropriate link in the nodejs file. However, this link will be removed once you reinstall your dependencies again. So if you don't want to lose this link after every npm installation, you have to provide save flag. And in this case, if you run it like that, you will see that the package has been successfully installed, and inside the package.json file right here, it added this decoded frontend build info package, and the file points to the package inside my file system on my computer. And obviously there was created the link inside the node modules. You can find this decoded frontend namespace, and you can see that it was linked with my project I created right here. So awesome, and it means that now we can actually run our custom architect target, this one, and it should work, at least in theory, right? So let's try to run this script, and you can see that the builder has been successfully executed, and the message that we defined right here was logged out in the terminal. So it means that our builder package has been successfully linked and the builder itself works properly. And now let's bring some useful logic into this builder. So first of all, let's create here a big try catch block, and inside the catch, if some error happened, we immediately return the object with success property set to false, right? And there inside the try, we are going to write some build logics. And as I said in the very beginning of this video, this builder is going to patch this build.json file and update the data right here. So let's get reference to this build.json file in first place. So I'm going to create a constant with a name like file to patch, and it's going to be the path to the build.json file. And first of all, I would need to get a path to this Angular workspace where I run my builder, and I can do that actually by reading the workspace root from the context object. But we have to normalize the path of this string because it is not normalized, and in order to do that we have to import a couple of helper functions called normalize and get system path. And first of all, we have to call the normalized function, and then we have to wrap it also with the get system path, the normalized string. And after that I get the reference to the application workspace root folder, and from there I have to navigate to the source folder, assets, and then I can get reference to my build.json file. So let's do that. So this is the source, then assets, and here is my build.json file. All right, I will zoom it out a little bit to see more code, and then we can proceed. And the next step actually to fetch the application version from the package.json file in our application. So we have to read this property right here, right? So let's get back and create a reference to this package.json file as well. So here's the constant that has a name package.json content, and here I'm going to read files synchronously, and I'm going to import the appropriate function from the file system nodejs package. So here I have to do something similar to what I have right here. So I can copy the normalized path to my workspace root, right, and place it here, and then I just type package.json like that. Here we go. And I believe I forgot to define the encoding, and it's going to be UTF-8 like that. So save it, and now let's move forward. Once we have references to both files, like files that needs to be patched, and now we have the content of package.json file, now we can update this file and insert the proper data inside. I can do that by calling the write file synced method that comes also from the file system npm package, and here I have to provide the file that I'm going to patch, right? And here I need to provide the specific object that needs to be stringified, right? So let's use the JSON stringify method right here. And what I have to provide, it is actually inside the build.json. Okay, there needs to be the property version and date. So let's create a version property, and the version is going to be the version that we read from the package.json file. So sorry, I have to parse this content first. So here we go, and the second one is a date, and it's going to be some date string, I don't know, something like that, or you could use the timestamp, whatever. So I can save it, and it's supposed to work. So we can jump back to our target application and rerun our builder one more time. As you can see, it was like patched successfully, no errors there, and you can see that the value of the builder.json has been also updated. It got the current date, and also it got the current version. If I change it to, for instance, this version and rerun it, you will see that it is also reflected inside our builder.json file. The only thing I don't like, it is not formatted, it just inserted like that. So I will add some properties to the stringify method, namely we have to provide undefined here for the replacer function, and there I can define as a third parameter the amount of spaces that needs to be inserted. So if I save it now and then go back to my target application and rerun it, you can see that now it looks way more better rather than just one line string. All right, so the basic functionality is working right here. So our file is being patched, but I would like to extend the functionality of this builder and bring some more customization, because for instance, build.json file is hard coded and I want to provide option where the user can define their custom path to this build.json file, and in such a way make it a bit more flexible. So let's quickly do that. As I said, options we describe inside the schema.json file that belongs to some particular builder, and inside properties we can define already the available options that could be provided for this builder. And here the key is going to be the name of the option. Then we have to describe it, so we have to provide the description for this option. And let's drop some string like that. And then we have to define the type of this property, which is, in my case, is going to be a string. And then the third property of this option is going to be the default value. And the default value, let's say, let it be the default source asset builder.json file. Okay, it looks like I have an error. What's wrong? Okay, I forgot the column. Okay, here we go. So we describe the option here, and it means that it will be available inside options property, inside the builder callback. Yeah, and to have strict typings, let's create the appropriate interface right here, and I'm going to call it build info options or something like that. And this option has to extend the following interface called JSON object that comes from the Angular dev kit core. And here I say that we have a property that has a name file to patch, and it is a string, right? So it means that here I could first I have to define that it has the build info options interface, and then from here I can destructure already the file to patch property, and then replace this thing right here instead the hard-coded value. So now it means that I can go to my target project, and inside Angular.json for this builder I can introduce a property called options. So like that, and here I can provide the property I just created, namely it's called file to patch, right? And here I can provide some alternative file that needs to be patched, and let it be some source assets and I know custom build JSON file, whatever. And now if I rerun my builder, we should see the custom build JSON file that that was created, and here you can see the application build data inserted, which means that options are working fine, which is really cool. But I also want to show you another cool feature, and namely we will trigger another architect target from our builder. This is really can be useful thing. So for instance, I want to execute patch build in for target architect target, and once the file was patched, I want to schedule the application build or serve application, so something like that, and we can quite easily achieve it, and let's figure out how to do that. So first of all, we would need to introduce a new property for our options. So let's name it like target to run. That might be optional, and it is also a string. And we have to obviously describe this property inside the schema. So here below I create target to run, and here I will add also some description, so something like that. And we also have to define the type of this property, that is going to be string as well. So here we go. Now this option should be available, and we have to run some logic that has to trigger or schedule some certain target. So let's do the following thing. Once we patch the file, first of all, we can notify the user by logging some message that patching has been completed. And we'll also do the following check, that if there is no target to run, that I has to also destructure from options, right? And if there is no target to run provided, then we return object with success true, means the builder has been executed properly, there is nothing to do else, so we exit from this script and complete the script. Otherwise, if the target is provided, we go further and we will execute the following logic there. Here from the context object, I can schedule the target, right? And here we have to describe the target object. This object has a property target where we have to define the target we want to execute. So this is something what a user will provide to us. So we will provide it also here. Then it has also project property that we also can read from the context, and namely from the target property. And here is the project. So it means that it needs to be executed in the same project, namely this one, right? And then we have to also provide a configuration that has to be the same as the current target. So we can read the configuration from here as well. So it can configuration, this is like production, development, and so on and so forth. So this scheduled target, it returns promise. Right, so we can await for it, and in order to use await keyword here, we have to make this function async like that. And we would also like to assign the result of the scheduled target execution into some constant. Let's name it build like that. And after that, I will destructure the success property from the result of this build execution, right? So it has a result which is also promise actually, so we have to await when this promise will be resolved as well. And once we have done it, once we have the result of this build, we can return the final result of this of the builder execution, right? So this is the object where the success property is equal to the success that returned this build result. So it will be like that, or we can, in modern JavaScript, we can simplify it to this simple string. So here we go. It looks like we are done, and let's try to test it out. So I'm going to go to my target project and go to the options, and here target to run is going to be what will we build? Let's maybe try to execute serve target right here, and let's maybe remove it temporarily like that. And now let's try to execute our builder one more time. And as you can see, the patching has been completed and there was scheduled the target serve, and currently my application is being served on localhost 4020, and I can go there and you will see that the application version has been updated and the build date was updated as well, which is really, really cool. And actually, you can also play with configurations already, because they are kind of work out of the box. Once you have options, feel free to introduce your own configurations. Like you might have some maybe production configuration. For instance, you would like to schedule the target build for the production. I don't know, it's like stupid example, but just to demonstrate you that it works. So for instance, you want to schedule the build target for production, and for development. So let's change it to development. And for development, for instance, you want to serve the application, right? And then you can run the command. Okay, I have to stop this one. You can run this command and provide the configuration other third parameters. So the first one is a project name, then goes the target, the target itself, and the third parameter, it could be a configuration. For instance, it could be a production, right? So I will run it with a production configuration, and you can see that the build.json file has been patched and the application has been built. But when I run it in development mode, then it will be executed and application will be served. So the serve target has been involved. Also, you can define the default environment, for instance, like that. And let's say that the default environment is going to be production. Yeah, why not? So I save it like that, stop the execution of this current build run, and then I will just remove those stuff and I run it as it is. And you can see that by default there has been production configuration taken and executed the target build eventually. All right, so this video was quite long, so let's quickly recap what we have learned in this tutorial. So first of all, we created a custom architect target inside the Angular JSON file. We described the builder for it, and builder points to the decoded frontend built-in for npm package and calls the patch builder. When Angular CLI executes that, it goes to this package that we have created right here, and it starts to parse the builder's JSON file and finds the patch builder as we defined right here. Then it goes to the implementation that leads us to the nodejs script that is compiled from the from the TypeScript sources that lives under the source folder. And here also we describe the schema.json file that describes the available options for this builder. We also created some build or compilation pipeline in our library. Actually, we created the build command that just compiles TypeScript. After the build is executed, we copy JSON files, namely the schema.json file, into the dist folder. Then we created the third very helpful script that runs a compilation in watch mode, and every time when TypeScript successfully compiled files, we re-execute post build command that will move again schema.json files under the dist folder. The logic of our builder is quite simple one. Every Angular CLI builder can be created using this helper create builder function that takes some callback that returns some specific object that should have at least one property called success, which is Boolean. It can be the observable of this object as well. It can be a promise like we do right here, or it might be just a plain object that has this success property. This callback function takes two options, the options that we described in the schema.json file right here, and the second parameter is the builder context. Builder context is an object that exposes a lot of useful helper functions and other properties. For instance, it exposes the logger object that allows us to print some messages into the console. Then we can here write or read different files and modify them. This is exactly what we are doing here. And also we can schedule some another targets by calling schedule target method of the context object, and we can provide any string of the target that matches one of the targets there in the Angular JSON file, and in such a way we can execute another target and then read the result of this execution and return it. So in such a way we can be really very flexible and execute really complex scenarios using our custom builder. Alright guys, we are done for today, and please let me know in the comments if the information was useful, and if so, please support this video by hitting thumbs up and sharing it with your colleagues and friends in any social media you like. If you want to level up your career and improve your Angular skills, you can check out my video courses that are currently available with 20% discount because of upcoming Christmas holidays. So don't forget to follow the video description and find all necessary links and discounts there. Follow me also on my other social media where I constantly publish some short front-end tips. I call them front-end snacks. So if you are always hungry for new knowledge about front-end development, then you definitely have to subscribe to it. Otherwise, I wish you a productive week ahead, stay safe, and see you in the next video.